Some say the power grid is among our greatest engineering achievements. This amazing machine is currently undergoing a massive transition. Experts agree that global power grids will see more change in the next 10 years than has occurred in the past century. Coal plants are retiring, while natural gas and renewables are becoming much more prevalent. Distributed generation and new load patterns are making the grid much more uncertain. This makes it challenging for utilities to accurately predict future problems and identify solutions. These days, new lines are very difficult or sometimes impossible to build. With environmental and NIMBY concerns, rebuilding existing lines to carry more power is often just as difficult. After a century of increasing demand, load growth has leveled off for many grids. This means utilities must charge more for each unit of energy they deliver in order to make the necessary investments in their aging grids. What does this all mean? Problems are becoming harder to accurately predict. The grid we need is different from the grid we've built. Utilities are feeling pressure to better utilize the grids they have already built. Utilities are demanding more flexible tools and need options that are quickly deployable. SmartWire's game-changing solutions help utilities gain higher transfer capacity from the grids they have today. A little bit about the grid. Power typically flows from generation to load over high-voltage transmission lines that connect substations. This simple diagram shows 3 lines connecting generation and load. The first power line is overloaded, but there is plenty of excess capacity on the other 2 lines. In almost every power grid across the world, the excess capacity of the other 2 lines can't be used. Why? Because power follows the path of least resistance. In electrical terms, we call this impedance. The first line is overloaded because its physical characteristics yield a lower electrical impedance than the other 2 circuits. Since things like the line's length and the conductor type determine the line's impedance, power is rarely balanced across a set of parallel lines. The smart valve is a revolutionary device that changes the impedance of power lines in real time. This technology gives utilities a controllable valve that can be easily adjusted. For the first time, utilities can manage their grids with total control over where the power flows. How can the smart valve resolve this overload? 2 ways. First, the smart valve can be installed on the overloaded line to increase the impedance of that line. This pushes more power down the other 2 paths. Alternatively, the smart valve can be installed on the least utilized line to lower its impedance. This pulls more power down the path with spare capacity and off the overloaded circuit. The result is a dramatic increase in overall power transfer across this area without replacing, upgrading, or adding any costly new infrastructure. The smart valve has many flexible deployment options, including existing transmission towers, in substations, or on a mobile trailer. SmartWires was built for today's grid, where utilities face significant uncertainty regarding their future needs. This technology installs quickly, is modular, and can be scaled easily, and is completely redeployable. It's time to reimagine the grid. It's time for SmartWires.